tayo ng Math-aral. Sa Math, walang maiiwan. Math-sayang Math-aral, tayo ng Math-tuto upang ikayo masenso. Maging matyaga, maging matalino, halina Math-aral na tayo. Maging matyaga, maging matalino, halina Math-aral na tayo. Halina Math-aral na tayo. Halina Math-aral na tayo. Halina, 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 aral na tayo.
Good day, Batang MANDunong. I'm Mrs. Elizabeth M. Lontayo, a senior high school faculty member of Eloyo Rodriguez Integrated School. Your lecturer for Quarter 4, Week 3 on series of online academic review. I am with Ms. Jamaica Torres, our sign language interpreter for senior high school inclusive education. Join us and learn about test of hypothesis. Objectives. At the end of the learning episode, you are expected to 1. Determine and elaborate the following terms. A. Null hypothesis. B. Alternative hypothesis. C. Level of significance. D. Rejection region. And E. Types of errors in hypothesis testing. Number 2. Determine the parameter to be tested given a real-life problem. And number 3. State the null and alternative hypothesis on the population mean. Let's have a recall on terms you have learned last episodes. What is normal curve distribution? Yes, it is a bell-shaped curve wherein two tails can be extended indefinitely without touching the horizontal line. What is confidence level? Confidence level refers to the probability that the confidence interval contains the true population parameter, while alpha is the probability that the confidence interval does not contain the true population parameter. What do you call a line that divides the acceptance region and the rejection region? Yes, critical value. Critical value is the value that indicates the point beyond which lies the rejection region. I will show you the illustration. So as you can see here, we have a critical value on the left side and on the right side. On the left side, we have a critical value of negative z sub alpha over 2, and on the right side, we have the critical value z sub alpha all over 2. Then beyond this is the rejection region. So this one is the rejection region on the right side, and this one is the rejection region on the left side. And at the center is the confidence level. As we go through this, you can see the relationship exists on the level of significance, the rejection region, and the critical value. Alright, let us start. Let's begin with the hypothesis. A hypothesis is an educated guess about something in the world around you. It should be testable, either by experiment or observation. It is an assumption or conjecture about a population parameter which may or may not be true. Examples: a new vaccine for COVID-19 you think might work. Remember, it is testable using an experiment. Or, a way of teaching in the new normal you think might be better. It is also testable through observation. Or even an experiment. Remember, it can really be anything at all as long as you can put it to test. Hypothesis testing. Hypothesis testing is a decision-making process for evaluating claims about a population. It is basically testing an assumption that we can make about a population. These are assumptions that may or may not be true. There are two types of statistical hypothesis. The first one is the null hypothesis, and then the second one is the alternative hypothesis. The null hypothesis is denoted by the symbol H sub 0, while the alternative hypothesis is denoted by H sub 1 or H sub A. When we say null hypothesis, it is a statement stating that there is no significant difference between population parameter and the value that is being claimed. It is also the hypothesis to be tested, while an alternative hypothesis is a statement stating that there is a significant difference between the population parameter and the value that is being claimed. It is also the hypothesis considered to be true once the null hypothesis is rejected. So let us discuss further about null hypothesis and alternative hypothesis. In a null hypothesis, using H sub 0 as symbol is a claim that denotes absence, such as absence of difference, absence of relationship, or equality to a certain value, and the like. It usually comes with equal sign, greater than or equal to, or less than or equal to when written in symbol. While alternative hypothesis is a claim that denotes presence, such as presence of difference, presence of relationship, or inequality in a certain value, and the like. It usually comes with equals, not equal to, greater than, or less than when written in symbol. Okay, in other words, the process of hypothesis testing involves making a decision between two opposing hypotheses, the null hypothesis and the alternative hypothesis. These two hypotheses are formulated in such a way that one is the negation of the other. For example, if we make use of equal sign, the negation of this is not equal to. If we use greater than or equal to, the negation of this is less than symbol, while for less than or equal to, the negation of this is the greater than symbol. If one is true, the other one must be false. Let's have an example. Tell the null hypothesis or H sub 0 or the alternative hypothesis or H sub A of the following. For example number 1, the null hypothesis is written in words. The average IQ of grade 11 learners is 110. Now we need to negate this statement. What will be its negation? Correct. The average IQ of grade 11 learners is not 110. Example number 2. The given here is an alternative hypothesis. The average content of yogurt drink is less than 330 ml. What is its negation? Remember, we make use of the word is less than. What is the negation of is less than? Correct. The average content of yogurt drink is greater than or equal to 330 ml. For example number 3, it is written in symbol. Remember, the symbol is for the population mean, or we call it as mu. Mu is equal to 20.5. What is the negation of the symbol equal? Correct. That is not equal. So mu is not equal to 20.5. Example number 4. The given here is an alternative hypothesis. Mu is not equal to 15. So then again, we need to negate this symbol. What is the negation of not equal to symbol? Correct. That is the equal symbol. Therefore, our null hypothesis is mu is equal to 15. And number 5, given an alternative hypothesis, mu is less than 3.5. What is the negation of the symbol less than? Correct. Mu is greater than or equal to 3.5. Okay, another example. A social worker wants to test at alpha, which is equal to 0.05, whether the average body mass index or BMI of pupils under feeding program is different from 18.2 kilograms. Letter A, state the null and alternative hypothesis in words. And letter B, state the null and alternative hypothesis in symbol. Okay, in words, the null hypothesis here is the average body mass index or BMI of pupils under feeding program is not different from 18.2 kilograms. While the alternative hypothesis is the negation of the null hypothesis, which is actually the claim in the given example. The average body mass index or BMI of pupils under feeding program is different from 18.2 kilograms. How about letter B? We need to state the null and alternative hypothesis in symbols. So, the null hypothesis is mu is equal to 18.2, while the alternative hypothesis is mu is not equal to 18.2. The next term is the level of significance. The level of significance is the probability that the test statistic will fall in the rejection region, when in fact the null hypothesis is actually true. The level of significance, using the Greek word alpha or using the symbol, corresponds to the rejection region, and 1 minus alpha corresponds to the acceptance region. The most used values for alpha are 0.01, 0.05, and 0.10. The next term is the rejected region. The following table shows the location of the rejection region under the normal curve depending on the null and alternative hypothesis for the population mean. So, the relation symbol in the hypothesis, we have here a null hypothesis for the first column and then the second column for the alternative hypothesis. If the null hypothesis makes use of equal sign and the alternative hypothesis makes use of the not equal sign, then the test to be used is two-tailed. Where will be the location of the rejection region? It is located to the left of negative z sub alpha over 2 and to the right of z sub alpha all over 2. When the null hypothesis is greater than or equal to and its alternative hypothesis is less than, then we make use of the left-tailed test. So, where is the location of the rejection region? It is to the left of negative z sub alpha. While, if the null hypothesis is less than or equal to and the alternative hypothesis is greater than, then we make use of the right-tailed test. Where is the location of the rejection region under the normal curve? It is located to the right of z sub alpha. Let us consider the illustration below to differentiate the rejection region, the level of significance, and the critical value from one another. We have here an example of a two-tailed test wherein there are two critical values involved. We have negative z sub alpha all over 2 and we have here positive z sub alpha all over 2. Here the rejection region is beyond the critical value on a positive side and the critical value on the negative side. Critical value refers to the z value. After identifying the hypothesis to be tested, the next step is to convert the sample mean to a value called test statistic. This value will guide the researcher in making decision and draw conclusion. The level of significance and the probability that the test statistic will fall in the rejection region when in fact the null hypothesis is actually true. Types of errors. Type 1 error is committed when the researcher rejects the null hypothesis and when in fact it is true. The probability of committing one type 1 error is also called the level of significance. While type 2 error is committed when the researcher fails to reject the null hypothesis that is false. But if the researcher fails to reject a true hypothesis, then there is no error committed. Let us consider the table. The first column is all about the decision, and then the second column, which is subdivided into two, is the true state of nature. If the null hypothesis is true, or if the null hypothesis is false. If the null hypothesis is true and accepted, or if the null hypothesis is false and rejected, the decision is correct. If the null hypothesis is true and it is rejected and the decision is incorrect, then this is a type 1 error. While if the null hypothesis is false and it is accepted, the decision is incorrect, then it is a type 2 error. In an ideal situation, there is no error when we accept the truth and reject what is false. One-tail test. The rejection region is on one side of the distribution. It is either on the left or on the right tail of the curve depending on how the alternative hypothesis is stated. This is considered as directional. The total area of alpha corresponds to the rejection region is placed on one tail only. The alternative hypothesis uses greater than or less than an equality symbol. Let's have our first illustration. Okay, it is a one-tail test because the alternative hypothesis uses less than symbol. Okay, if we make use of the less than symbol, then our rejected region is located to the left side of the critical value. Okay, let us shade the rejection region. Okay, this is our rejected region. The yellow one is the rejected region. While on the second illustration, it is also called a one-tail test because the alternative hypothesis makes use of the greater than symbol. Then again, if we make use of the greater than symbol, then the shaded part will be on the right side of the critical value, meaning the rejection region is on the right side of its critical value. So let us shade it. This is the critical value and this is the shaded part. The shaded part is the rejection region. So again, the one-tail test makes use of the less than symbol and the greater than symbol. The two-tail test. The rejection region is on both sides of the curve. This is a non-directional. The value of alpha corresponds to the rejection region is divided equally between the two tails. The alternative hypothesis contains the not equal to symbol. So as illustrated, this is our critical value. We have the negative z sub alpha all over 2 and positive z sub alpha all over 2. The rejection region is on both sides of the curve. So from the critical value going to the right is the rejected region, and then from the critical value again going to the left is the rejected region. Now let us shade the rejection region. So this is the rejection region on the right side, and this is the rejection region on the left side. Now let us combine what we have learned a while ago in this given example. The subject group coordinator of PE Department of Parañaque National High School Main Senior High School program claims that the height of grade 11 students is 162. The mean height of 50 randomly selected STEM students is 160 centimeters. Use 0.05 significance level. Number 1, we will state the null and alternative hypothesis. Number 2, what type of test is applicable? Is it one-tailed test or two-tailed test? Number 3, we need to compute for the critical value. And number 4, illustrate using the normal curve. Okay, so let's start with stating the null and alternative hypothesis. Remember that they claim that the height of grade 11 student is 162 centimeters. So let us state the null hypothesis is mu is equal to 162, meaning to say the height of grade 11 students is 162 as their claim. To negate this, all alternative hypothesis will be mu is not equal to 162, or the height of grade 11 student is not equal to 162 centimeters. Number 2, what type of test is applicable? Is it one-tailed or two-tailed test? So take a look again the symbols being used in the null and alternative hypothesis. Is it one-tailed or two-tailed? Since the alternative hypothesis uses not equal to symbol, therefore it is a two-tailed test, or it is applicable for a two-tailed test. Next is to compute for the critical value. How are we going to do that? To find the critical value, letter A, we need to find alpha. It is the significance level 0.05, which is already stated in our problem. Divide alpha by 2 since two-tailed test will be employed. So 0.05 divided by 2 will give us 0.025. Next is to subtract 0.025 from 0.5. Then we come up with 0.4750. Locate 0.4750 to Z table and get the corresponding value of Z. So Z sub alpha all over 2 is equal to 1.96. At 5% significant level, the critical value is positive and negative 1.96. Since we are dealing with a two-tailed test, we have two values, positive 1.96 and negative 1.96 for its critical value. Next is to illustrate this. So, since we have a level of significance of 5%, our acceptance region is 95%. So, this is a rejected region. Remember, our critical value is 1.96. So, here is 1.96. Negative. And this is positive 1.96. Okay, next example. The director of a teleserye, Ang Probinsyano, claims that the mean number of people watching their show is 800,000 each day. A student researcher wants statistical evidence on the claim. That is why she conducted her own study. Her study resulted to a mean of 500,000. Using a 0.10 significant level. Number 1, state the null and alternative hypothesis. Number 2, what type of test is applicable? Is it one-tailed test or two-tailed test? Number 3, compute the critical value. And then number 4, illustrate using the normal curve. Okay, solution. State the null and alternative hypothesis. So, according to the claim of the director of the teleserye, Ang Probinsyano, the mean number of people watching their show is 800,000 each day. So, the null hypothesis states that the mean number of people watching their show is 800,000. While the alternative hypothesis states that the mean number of people watching their show is less than 800,000. Okay, why did we come up with the less than symbol? Because the student researcher resulted to a mean of 500,000, which is less than 800,000. Next, what type of test is applicable? Is it one-tailed test or two-tailed test? Remember, the alternative hypothesis makes use of less than symbol. So, since we make use of the less than symbol, therefore, it is a one-tailed test. Okay, next is to compute for the critical value. So again, to find the critical value, letter A, find alpha. And it is the significance level 0.10 as stated in the problem. Subtract 0.10 from 0.5. So we come up with 0.4000 or 0.4. Then we need to locate 0.4000 or 0.4 to z value. Since there is no 0.4 to z table, consider the nearest value, which is 0.3997. And to get the corresponding z value, z is equal to 1.28. Next, at 10% significance level, the critical value is 1.28. Let us illustrate the given in the normal curve. So this is the illustration. Since we have a 10% level of significance, then our acceptance region will be 90%. So this is the acceptance region. Then this is the critical value. The critical value that we had a while ago is 1.28. Now, why is it located on the left side? Because we make use of the less than symbol. Okay, so from the critical value going to the left, this is our rejected region. So this is our rejected region, the shaded part. Okay, so to wrap up quarter for week 3, which is all about test of hypothesis, we have defined the following terms: null hypothesis, alternative hypothesis, level of significance, rejection region, and the types of errors in hypothesis testing. We also determine the parameter to be tested given a real-life problem, and we state the null and alternative hypothesis on the population mean. For this, thank you so much for listening. Also, special thanks to SDO Mandaluyong, our Education Program Supervisor, Recituto I. Rodelas, our Principal in ERIS, Mr. Romeo E. Bandal, our Head Teacher in Mathematics at ERIS, Mrs. Cynthia M. Delino, my partner, Jamaica Torres, also a good friend of mine, Amelita A. Ibanez, for the technical assistance, a dear colleague at MPNEG, Mary Ann Yusi, our home learning partners, ERIS senior high school learners, and of course, Batang MANDunong. Keep safe everyone!